Electrical wiring in buildings is concealed wherever possible. The portion of the work accomplished before concealment is called roughing in. Here is the ceiling fixture, and above its canopy is the outlet box where the fixture is attached mechanically to the ceiling and electrically to the wires. This is the wall switch which controls the ceiling light. It controls the operation of the light by opening and closing the circuit. The wall receptacle, usually called a convenience outlet, provides the point of connection for radios, portable lamps, and other electrical equipment. The roughing in can be speeded up by first planning the locations of the various runs. The wires in this cable from the distribution cabinet run across the ceiling to the ceiling outlet box. This is the switch loop, the cable that will connect one side of the line through the switch to the fixture. The wall receptacle run extends the line across the ceiling and down the other wall to the wall receptacle box. With the point of entrance established, determine the location of the runs. This blueprint covers the entire floor plan for the building. This section gives the data needed for roughing in this room. Mark the location of the runs on the blueprint. First, extend the circuit cable to the ceiling outlet box. Then draw the switch loop run. Then make the run to the wall receptacle. Drawing these runs on the print provides a record for future alterations or maintenance. Before measuring for any installation, the blueprint scale must be checked. On this print, 1/4 of an inch equals 1 foot. The location of the ceiling outlet is checked on the blueprint and is found to be in the center of the ceiling. Count the joists to help determine the center of the ceiling. A bar hanger is used to fix the center position of the outlet. The bar hanger offset holds the outlet box a distance behind the plaster line so the box edge will be flush with the plaster finish. Also, the hanger must support the weight of the fixture. The stud on the bar supports the outlet box and the fixture. It is made to slide along the bar so that the outlet box can be moved into position. The locations of all outlets are determined from the blueprint and job specification sheet. The blueprint shows that the wall switch is to be located near the side of the door opposite the door hinges. Otherwise, the position of the switch would be inconvenient. This specification sheet states the distance from the finished floor to the switch to be 4 feet. In locating the switch box, place it as near the door as possible, but allow room for the door casing. The third outlet, the wall receptacle, must also be located. The blueprint locates the wall receptacle 6 feet from the corner. This job specification sheet also states the height of the wall receptacle above the finished floor. Nail the receptacle box parallel to the stud. Otherwise, the receptacle plate will not be straight and will detract from the appearance of the room. The outlet box knockouts must be removed to provide entry for the cables. This 4-inch outlet box has 9 knockouts. 3 holes are required for the cables, plus 1 for mounting the outlet box on the bar hanger stud. For this job, use top knockouts. If side openings were used, the later application of plaster might crowd the cables. Entry from the top eliminates bending the wires at right angles inside the box when they are worked on. Remove the knockouts. Mount the box on the bar hanger. Then move the box along the hanger to the exact center sealing position. Now tighten the screw firmly. The circuit cable is now run to the outlet box. To support the cable securely, straps are placed approximately every 2 feet, which is well within the code requirement of 4.5 feet. Cable must be strapped within 12 inches of an outlet box. With the cable completely strapped, the length of wire needed for connections in the outlet box is determined. At least 6 inches should be left beyond the box. The cable braid is stripped. The paper wrapping is removed to expose the insulated wire. A connector to fasten the cable to the outlet box is clamped to the cable braid. The wires and connector with lock nut removed are pushed through the outlet box and will be held securely in place by the lock nut. The concave side of the lock nut must be against the box to ensure locking. path for running the switch loop to the wall where the switch is located is obstructed by the joists. Because the cable is to be concealed, it must be run through these joists, and to do this, holes must be bored. To determine the size of the holes to be made in the joists, measure the diameter of the cable. This measurement indicates that an 11/16 inch or a number 11 bit should be used. Always keep the bit sharp. File the cutter on the top only, and the lip only on the inside. A boring machine is used so that the work can be done from the floor. Be sure the bit is tight before starting. Adjust the boring machine to approximately the center of the joist. This will avoid the possibility of nails striking the cable during later construction. To bore the hole in the plate, a brace, extension, and bit are assembled, the same sized bit as was used in the boring machine. Enough cable is uncoiled to make the switch loop. The cable is then run through the plate. Now it is pulled through the joists onto the outlet box. Leave enough cable to extend into the outlet box. The code requires that at least 6 inches of free conductor shall be left at each outlet and switch point for the making up of joints or for the connection of fixtures. Straps must be placed wherever there is any strain. Pull the slack out of the cable and strap it to the last joist. Strap the cable along the side of the stud. Then cut the cable, leaving enough for entry into the switch box and for attachment to the switch. To make an entry for the cable into the switch box, insert a screwdriver into the knockout slot and pry out the disc. This type of switch box has a clamp to hold the cable. Other types of switch boxes require the use of connectors, such as those used in the ceiling outlet box. Fill the box with paper to prevent it from being plugged with plaster. Bore the hole in the plate above the wall receptacle and install the receptacle run. The wall receptacle run is strapped to the ceiling joist. The run is also strapped to the stud. The last strap must be within 12 inches of the outlet box. This completes the roughing in of the receptacle run. To complete the circuits of the runs, the ends of the conductors in the outlet box must be joined. Use pigtail joints for this purpose, as this type of joint requires less room and can be packed more easily into the box. Only 2 pigtail joints are needed. One end of the switch loop and one tapped end of a circuit wire are left for connection to the fixture. The pigtail joints must be soldered before taping. The National Code requires that all joints and the free ends of conductors shall be covered with an insulation equal to that of the original conductor. Start both rubber and friction tape between the wires. Otherwise, the tape might slip off. Too often the tip of a pigtail joint is not thoroughly insulated. Be sure to draw the rubber tape beyond the tip. Then double the tape before stretching it over the joint. Cover the joint with friction tape. The rest of the rooms are laid out and roughed in using the same methods as in the living room. After inspection, the fixtures, receptacles, and switches will be installed. In brief review, roughing in non-metallic sheathed cable consists of installing that portion of the wiring which will be concealed in the finished building. This includes various runs such as circuit wires, switch loops, receptacle runs. Careful attention to the planning and workmanship helps to assure efficiency in the job of roughing in non-metallic sheathed cable, which must meet the requirements of national and local codes.